Welcome back. Let's start talking about section 4, and this is chemical reactions. So, chemical reactions, and how do we know that a chemical change is taking place? And you're going to have certain types of reactions to remember. So, words such as burn, rot, rust, decompose, ferment, explode, corrode almost always indicate a chemical change has taken place. The ability of a substance to do these things is called a chemical property. Iron is able to combine with oxygen to form rust, and this would be a chemical property. We've already talked about that being a chemical change. So if you think it's a chemical change, then it is a chemical property of that substance. So they are very closely related terms. Chemical properties can be used to identify a substance. If I wanted to identify a substance, I could use a chemical change to identify it, a series of reactions that I might use. So charcoal can be broken down into smaller and smaller pieces. That would still be a physical change, right? But it may represent an ability for the pieces to react better because they have more surface area, but it would not be a chemical change, it would be a physical change. So the composition of the matter has not changed. It's still charcoal no matter how small I make the pieces. During chemical change, the composition of the matter always changes. I make something new. So if I were to say something like, water decomposes using electricity to form hydrogen and oxygen, that is a chemical change because I formed new substances. So when I heat charcoal and I use it to maybe cook food on a barbecue grill, now the charcoal is reacting with oxygen in the air and it's forming new substances. It's also generating heat and light. Chemical change is called a chemical reaction. So that's one of the vocab words I'm going to ask you to know. And always there will be new substances formed. So chemical reaction is represented by a chemical equation. And in a chemical equation, on the left side we have reactants, and on the right side we have our product or products. And they are always separated by an arrow or a set of arrows. So when we burn charcoal with oxygen, one of the main products would be carbon dioxide. What is always true of a chemical change that is never true of a physical change? I'll give you just a second to think of something. And in a chemical change, composition of the matter always changes. During a physical change, it does not. What are the 4 possible clues? Or how would you know that you've had a chemical change? Well, the possible indicators are a change in energy, so it could get hot or cold, change in color, production of a gas, or the formation of a solid or a precipitate. For example, when I burn natural gas to cook food, energy is released by that process. It could also be taken up. We've all experienced those ice packs that you break the ampule inside, you shake them, and the ice pack gets cold. That's an example of when a reaction would get colder, it would be endothermic. That's not a word you need to know, but that is getting colder. So when methane and natural gas chemically combine with oxygen, the energy is given off in the form of heat and light. Some of this is transferred to the pot and therefore to the food so that the food can be cooked over the lit burner. Energy causes chemical change to take place in the food, like an egg when I cook it. And so the food may change color. It will brown possibly. The egg white will go from colorless to a solid white. And there will be changes in the chemical makeup of that material. So if you see something while cleaning your bathtub, you might see that there's a ring of soap scum around the tub, and we know that that is an example of a precipitate. And we have to use pretty harsh chemicals to get that off. So a precipitate is a solid that forms and settles out of a liquid reaction mixture. And some bathtub cleaners that you use to remove it bubble when you spray them on, and so therefore we see that another chemical reaction is taking place, allowing us to remove that precipitate or change it back into the aqueous phase so that we can have it go down the drain. If you observe a clue that a chemical change but you cannot determine for certain whether it's taken place, what do we do then? Well, it could be the result of a physical change. For example, energy is always transferred when matter changes from one state to another. So if it goes from a solid to a liquid, like in the case of ice melting, it is taking up energy, and that's why it feels cold to you. It's taking the energy away from your hand to that physical change. And bubbles form when I'm boiling a liquid, whether it's water or anything else. If I open up carbonated beverage, a lot of bubbles are released. That's because it's under a huge amount of pressure, and so some of that pressure is relieved when you open up the valve or the lid on the Coke. If you observe that a chemical change and you're not certain, the only way to be certain is to test the composition of the materials that are formed after the change. So here we have an Alka-Seltzer tablet, and when it reacts with water, we get all these bubbles released, and this would be an example of production of a gas. When I put a litmus sheet of paper into water, if I put it into acid or base, the color can change. And this is what we do with pool chemistries. We use color changes to indicate concentrations of various species in that water to know what we need to do to our pool to keep it in good shape. And so this is a result of determining the pH. Making ricotta cheese is probably the easiest reaction you could ever do. In fact, if you wanted to do that, it's absolutely wonderful. I can direct you to the correct link to making homemade ricotta cheese. It takes a gallon of milk and like one or two other things. It's very, very simple. And what we do then once we've created that precipitate is we need to remove it from the watery substance, which is called the whey, and we make ricotta cheese. This is how they make also cottage cheese. Almost all cheeses go through this step. Ricotta is just the easiest to make at home. So, for burning a match, would that be physical or chemical, and how would you know? So, it is undergoing a chemical change because we're transferring heat, we're producing light, and we're producing a different material at the end. The end of that match is different composition than the part on the very right. How can you determine whether a chemical change has taken place? Well, the only way to be absolutely certain would be to test the composition of the sample before and after the change. Conservation of mass. I think I'll stop here and start your second part video here for you. Thank you for listening. I'll see you in class.